All right, good morning, everybody. I'm recording this time. Thank you for pointing out that I was not recording. That was very helpful. That would have really sucked if we got like halfway through it and nobody noticed. So we got a couple of comments on YouTube last time saying that they don't like the music in the background, and so we'll just do it without any music in the background, which is fine. They're probably listening to their own music already. We have a technical discussion this week, which I'll go into quite a lot of detail about this. I think it's very interesting, and I'm pretty stoked to have this issue resolved because this goes back to it was first posted in November or October, like during the beta, and it goes back longer than that. So I'm happy to have this resolved. So our style of lighting that we use a forward renderer, but it's a little bit fancier than that. It's basically doing the same thing that id Software has been doing in their games, which is called a clustered forward renderer. And basically what it does is it divides the camera volume up into these quadrants, and each section here stores a list of lights that intersect that volume, that little cell. We actually use quite a lot more than this, but this is a good visual guide representation of how it works. And so that allows the fragment shader to, whenever it's drawing a pixel, first it figures out which sector is that pixel within, and then it goes and it looks up the list of lights that intersect that sector, and that way you don't have to loop through every single light in the scene for every single pixel. It's been a very good technique for us, but it can produce, like our first implementation of this was producing some artifacts. And basically here on the right, this is what you would see, and this would happen on AMD cards. It didn't happen on NVIDIA cards, but it's not a driver bug. And actually, with LEDWorks, we even saw something similar. You would see like a little. Sometimes you would see a little like dividing line of like white pixels in between the stages of a cascaded shadow map with LEDWorks, and that was due to the same issue. It just wasn't as obvious as this. So what's going on here? Okay. Bindless textures are a very cool technique because it allows us to access all textures in memory at once in one shader. So instead of being confined to a very small list of texture samplers, which I think usually it's about 32 at minimum is like the minimum guaranteed value for most versions of most APIs. Bindless textures allow us to access textures, as many textures as we want. We can access like 1,000 textures in one single shader. This is very cool. Now, this was originally I implemented this in OpenGL before the engine moved to Vulkan, and I'm just using this extension because it's a little bit better explained. In Vulkan, I can recreate the same kind of behavior using some weird techniques, but it's not as well defined like in an extension like this. There might actually be a Vulkan bindless texture extension now, I'm not sure. But the way we did it is we just have like a big array of texture samplers, which works fine in Vulkan. The only issue with this is this weird, fairly obscure concept of dynamically uniform expression. And I'd be lying to you if I told you that I understood this completely. I don't think anybody does because it varies from hardware to hardware, the definition a little bit. So a dynamically uniform expression is a GLSL expression in which all invocations of that shader within a particular set of invocations will have the same value. Blah, blah, blah. What does that mean? Only GLSL 4.0 and above makes a distinction about dynamically uniform expressions. Any restriction you see that require a dynamically uniform expression will, in older GLSL versions, require a constant expression. An expression in the GLSL shader is said to be dynamically uniform if, and only if, every shader invocation within the same invocation group will have the same value. What is in the same order? What is an invocation group? It's vague. Whether an expression is dynamically uniform depends on the values provided. It cannot always be a priori determined from a shader's code. I don't even know what that word is. Some expressions are always dynamically uniform by the rules of the language. These include constant expressions, uniform values, any expression which does not involve a user-defined function call, image load store, or SSBO operations. What are SSBO? Shader, storage, buffer, something. Whose input values are all dynamically uniform. The GLDraw ID input to the vertex shader. Other expressions may or may not be dynamically uniform. For example, a shader stage input value will usually not be dynamically uniform. However, if every shader in the rendering command is given the exact same input value, then it will be dynamically uniform if it is value of the expression which must be uniform. Every shader invocation must get the same value, even if that same value is being read from different memory locations. GL instance ID is an example. If you render only to a single instance, then GL instance ID will be dynamically uniform for that rendering command. However, if you render multiple instances in the same command, it will not. The same goes for instanced array input values. Most important of all, if you execute a loop over values where the initializing expression, offset, and test condition all use dynamically uniform expressions, then the loop counter itself will be dynamically uniform. While accessing textures is guaranteed to be dynamically uniform if the texture coordinates are dynamically uniform, accessing image variables or atomic counters is not necessarily so. Those are modifiable memory, so each invocation group may not get the same value. If the image variable is read-only, then accessing it is dynamically uniform if the image coordinates and so forth are dynamically uniform. Okay, what's an invocation group? Because that came up and we didn't really explain what it is. Dynamically uniform expressions are based on shader invocations within the same invocation group. The definition of invocation group depends on the shader stage in question. For compute shaders, the scope is all invocations within a work group. For shaders launched through rendering commands, this gets more complex. Oh, good. Rendering scope extends to all invocations of all shader stages recreated to service a single drawing command. Wait. Rendering scope extends to all invocations of all shader stages created to service a single drawing command. Okay. This means that for fragment shaders, two distinct primitives in a rendering command are considered part of the same scope. This means that GL primitive ID is not dynamically uniform unless you render only one primitive. This is also why GL instance ID is only dynamically uniform when rendering a single instance. Instanced rendering is considered a single drawing command. However, there are drawing commands that create multiple scopes. The multi-draw rendering commands, including the indirect versions, have separate scopes for their separate drawing subcommands. So while doing instance rendering in a draw command places all instances in a single scope, rendering multiple lines with a multi-draw command with a base instance creates multiple scopes, one per internal draw. Note, the above information is based on GLSL 4.6. As such, this may not be entirely correct for earlier versions. They defined the idea of dynamically uniform, but they didn't really go into explicit details. However, since they are based mainly on the hardware rather than the compiler, this definition is really about the behavior of the hardware. It is not unreasonable to assume that they applied to older GLSL versions as well. So who understood that?
No.
Yeah, it's basically the way that I think about it is if you in practice what that means is your texture samplers in a variable have to be the same throughout that shader, and if you don't, then you get these little glitches where this is like undefined behavior. Yeah, I mean, I'd be lying if I told you that I understood what they were saying, and I don't. And I think it's not really. What's that?
So this occurs because you have used this bindless texture feature, right?
Yeah, basically, what the problem is, it's accessing a different, like, okay, so when this is one triangle, this is two triangles being drawn right here.
Yes.
So they're probably part of, let's just say it's per triangle. I don't actually know what it is, and I don't think anybody does, because I think it varies depending on the hardware. But what that basically means is if you're drawing a triangle, then if you have if you have a texture sampler variable, and that variable changes within the same triangle that you're drawing, then you're going to get these little artifacts here, because the output is undefined. It kind of goes crazy. It doesn't know what to do. And I imagine it as being like, when it's about to draw a triangle, it gets all of the texture samplers lined up in one batch or something, some little cache in memory or something that it has, and then it accesses them all. And so basically, the solution to this okay. Well, in Doom, the reason they don't have this problem is because they put all of their shadow maps into one big atlas. There it is. Looks like they use this 8192 by 8192 shadow map.
Also, they define for every shadow map a new area in one frame buffer.
Yeah, this is just one big shadow map, and they render it all into one. Each shadow map has like one little area allocated for it. It looks like they're all using all the same size, but as a result, they don't. That's what they did to avoid this problem here.
They have only one texture.
Yes.
In total.
Now we have another feature in Vulkan called array textures, and it's basically like a 3D texture, but the bitmaps get treated differently. With a 3D texture, like a volume texture, if you have like a 64 by 64 by 64 texture, then the next bitmap level down is going to be 32 by 32 by 32. So in other words, it's getting squeezed. The width and the height are getting squeezed down, but the depth is also being compressed. With texture arrays, array textures, they work a little bit differently. Like, they'll get squeezed. The width and height will get squeezed, but they still maintain the same number of layers. But they're basically the same thing. They just act a little bit differently. Of course, with shadow maps, it doesn't matter because we don't have bitmaps at all. But we do with some other things that I'll explain in a minute. So what I did is I moved all shadow maps, not into an atlas like Doom did, which that would work too. But I used an array texture. And so I start with like a 1024 by 1024 by, I think like a 32 array texture. And then if more shadow maps are needed, then I allocate a bigger texture and I copy the contents of the old shadow map into the new one. And when I did that, yesterday I got my AMD 6600 arrived by UPS. It's an Asus model, and I got a good price on it from Newegg.com. I plugged it in, and this is the result on the left. So basically, long story short, is that problem is basically solved. And so I was, with that, although the update isn't out yet for you guys, I marked it as solved, and I was very happy to do that because I'd say that was like the single biggest issue that I was concerned about. This goes back to October 7th. And I kind of knew all this stuff, like back in like December. I kind of knew all this already, just not in as much detail as I just laid out for you. So that is the resolution to this. Now, what I need to do next. Okay. one aspect of array textures is that they're all the same size. So that means all the shadow maps have to be the same resolution. I think what I'm going to do is I'm going to allocate one texture for directional lights and another one for point and spotlights. And I think by default, the directional light, it'll be 2048 by 2048. And then the point and spotlights will all be 1024 by 1024. And if we need to adjust that in the future, we can, there's a couple of different ways that we can, we could like make it bigger and like, do like a more of like a texture atlas thing where we can allocate different sizes. But my thinking is that'll be okay for now. And we can always like, if we want to add more to it in the future, we can, but let's just get it working first. I need to do this. So I did this with shadows. I need to do this with environment probes. Those are all using cube maps, and those are color cube maps. And some of them do have met maps actually. So what we need is we need to make a cube array texture, which you can make those. It's just like an array texture, except the number of layers is evenly divisible by 6. That's how you determine like how many layers a cube map layered texture has. And then this also caused a similar problem with, let me find it. With terrain. Oh, actually, I think it was in the same.
Yeah, it was on top.
I think that might have been a separate issue, actually, because he's saying it's gone. Here we see the same thing with terrain. Again, it's that random access. Basically, random access texturing it works, but it has to be under specific conditions, which are described in this idea of invocation groups. So you just have to be careful about it. But now we know like how to handle that. So I need to do something similar with terrain, where I think terrain textures will all need, like per terrain, will all need to be merged into a single array texture, and then this problem, I expect that will go away instantly and never be a problem again. Now, this was actually the big difference between high-end hardware and low-end hardware in the current day is support for bindless textures. That's the biggest difference. There's not, like, everything else is fairly trivial and easy to work around, but bindless textures are the one thing that are kind of a big issue that separates high-end hardware from low-end hardware. And in fact, we have, if you look in the shader family files, we have definitions for a set of shaders that works with bindless textures and a set of shaders that don't use bindless textures, and that's what the static and dynamic sections of those files. That's what those are. The static refers to static texture samples, which means bindless textures. Dynamic refers to dynamic texture samplers, which means when you don't have support for bindless textures. So this, as a result of doing this work, I wasn't counting on doing this yet. This is actually something I was going to postpone, but this actually makes it much, much more possible to make a low-end fallback, because that was like the primary like challenge in making that happen, was getting all those shadow maps merged into a single image. Now that that's been done, like writing a low-end fallback is fairly trivial. I think we could do it with like, the same requirements as like LEDWorks, same hardware requirements. But so, anyways, all of this is being worked out. You guys said that this was the single biggest issue that you were concerned about, and it's being worked out. And I mean, it's basically solved at this point. And as a result of that, this also makes it much easier to build an optional fallback for low end hardware. So wasn't planning on doing all of that right now, but I'm getting all of this knocked out. In addition, I think the graphical update that's coming in a couple weeks, I think it's also going to help with. Basically, I'm looking at object deletion very very carefully. I think this is going to help some of those rare, like hard to pin down behavioral issues that a few people are experiencing. I can't say for sure yet because if I can't produce the bug, it's very hard for me to solve it. But I am looking at that kind of stuff very carefully, and I think this is going to have a very beneficial effect on like overall engine stability. So that's any questions about the about this issue in particular before I move on?
You said something about changing the light map texture, like the light quality. Because in Cyclone, I actually had to do that manually. I actually had to tell each like spotlight if it was like a really big spotlight. I actually had to increase the texture limit. So do you expect that to be like a feature part of the light class? Where you just increase the texture size?
Are you talking about eliminating shadow acne?
Yeah.
So I wrote a little formula that basically what it does is it takes the let's see if we can go back to the screenshot of that. Yeah, so what we see here, the light is right up here, right against the wall. It's actually inside this sphere, and the sphere is just set to not cast a shadow. Not that it would anyway, since it's inside the sphere. But the light is right up against the wall. And normally you would see really bad shadow acne on this. You would see really bad banding. And unless it had a very, very large offset for the depth. And then down here at the same time, we see that shadow is very, very close to where the exact geometry. What I did is I took the dot product of the surface and the vector of the light hitting it, and then I used like a sine or a cosine value and came up with a formula where basically like the more, what's the term, like the closer the light, the more perpendicular the light vector is to the normal of that surface, the more the offset gets bigger as that angle, as it needs it. And then if the light vector is hitting the surface like dead on, then it has a very small offset. So it's very, very close. And that seems to, I think it's going to still require some like fine tuning to get the properties perfectly right. But I think that's going to be our best approach. So I do think that will solve a lot of those. Hopefully we can just come up with a formula that will solve that. I think if we just make it work like under one circumstances, then we can just take that texture size and those settings and multiply that value, and it should just be able to change based on the current values. I think that'll work.
Right. Well, I mostly had this issue with spotlights because I had spotlights at an angle and they had to be like really big and shine down, and got a lot of acne and lead works. And then I had to like increase that texture twice.
Yeah, and they were like sort of like a low angle to the surface.
Yeah, it was like a 45-degree or less than 45-degree angle.
Yeah, well, this is like a very, very small angle. I mean, this is like
Right.
a 5-degree angle.
But that's a point light, though.
Doesn't matter.
Yeah, all right. No, I just acne is like something that like was a real sticking point with me because I needed these lights at angles, and the shadows just look gross most of the time until I figured out I can increase the size of the shadow map.
Yeah, I think that is something that we can definitely improve. It might take some time to get the formula right, but yeah, that's the goal. I think I basically have the right formula now. In Leadworks, there was no attempt to correct the offset based on angle at all. And now,
I remember you tried to add noise to the shadow. There's still code in the light shader where you were trying to like noise the banding. It was like a weird fix, and then you commented it out because it was kind of dumb.
oh, okay. Well, I think what we're doing, I think
Yeah,
what I showed you
whatever.
now, I think that'll solve the problem.
Yeah.
Any other questions about this non-uniform? You guys all you got all that about the executions in invocations.
Yeah, sure.
Each execution of a shader stage within a rendering command is called an invocation, with a few rare exceptions. Invocations cannot interact with another. Let's see what it says about fragment shaders. I do want to know that. Fragment shaders once per fragment generated by the rasterizer. It may be executed more than this as helper fragment shaders. Instances may be used by the implementation. These instances, however, cannot write data. They exist mostly to compute implicit. So yeah, I mean, when you get like more detailed and like closer to the metal, so to speak, you actually get more fragmented behavior, because it's no longer abstracted. Now it's like, a lot of this stuff is very poorly defined. I think you would have to really like go and talk to each hardware vendor individually to find out exactly how they work, because I don't think this can be summarized. But anyways, that doesn't matter. The point is we don't have white spots on our shadows. Another thing to check out, let's see, this week, Andy90, he wrote an interesting blog about just a general overview of how to build an inventory and crafting system. And that's worth a read if you're interested in that. It's in the blogs here in the community. It seems like survival games are very popular right now, and I think the cost of producing artwork for those is not very bad, because it's all outdoors. I think we've talked before, like outdoor scenes are actually like great for indie developers. I think that's one of the major reasons that like people said that they wanted. So when I took this poll, AMD compatibility was the number one issue, and that's basically solved. It'll take me a couple more weeks to get that out, but the hard part is done. And vegetation system was the number two, and both of these things were ahead of everything else by a pretty wide margin. So, yeah, that's definitely a priority, and it'll be easier for me to get that working after this. I'm pretty much just going to port the vegetation system we had in Leadworks over to Ultra, because it was super fast and it worked great. And then after that, we can see if there's additional features that we want to add to it. So that's all the technical discussion I have for this week. And now I'll just open it up to general discussion and whatever questions that you have.
I guess the only concern I have is that when this update goes at live, I'm kind of worried that like some of my stuff won't work anymore, because I'm doing a lot of things with right now I'm doing a lot of things with like rendering like text sprites to a layer and all that. So I kind of like am very cautious, not going overboard in like doing like in my like coding project. I don't want to do like too much overboarding, because I'm worried that like some things might change. Do you think that like when this update goes live, everything should just work because it's talking to that ultra core layer, as you mentioned last week?
Yeah, it's I don't think there's going to be any. I don't think you guys will even notice it.
All right.
Like
Well.
except like some of the problems will be gone. I don't think there'll be any change in behavior at all. If
Mhm.
you have any custom shaders, then those might need to be revised a bit. But yeah, if you're just using the API, then I think the behavior it should be exactly the same, and I'm going to test it pretty extensively. I think we'll get 0.9.4 out. We'll push that over to the main branch on Steam, and then in 0.9.5 will be where the rendering fixes. These rendering fixes will come.
Mhm.
But yeah, it should. I mean, it's being it should have 100% continuity, and like we have the documentation and the is basically a spec that I adhere to. So I don't think there's going to be any visible changes on your end, except things that weren't working before will suddenly work on AMD cards.
Yeah. No, it's great. And also, do you think that this change will fix the zooming issue with the camera that I posted on the bug report?
No, because I don't think that's just the it's a that's a calculation problem in the calling routine. So it'll get fixed, but it doesn't really have anything to do with graphics.
Okay.
Yeah, it's just I'm calculating the intersection of the light with these funny
Yeah.
volumes.
Yeah, you can see the clusters when you zoom in, and it takes a while for them to update. Like you see all these like patches, and you zoom in and out really fast, or just zoom in.
Okay, that's actually something I didn't know. I didn't know there was a temporal aspect to it.
Yeah, like you still if the scene still renders, it's like the lights and shadows aren't not appearing. Like if you run the example, I know it's like kind of weird, but um because it works like fine if it's just like a default like cube or something, or it's like in the editor. That's probably why you didn't like notice it. But if you're like in a scene and then you like add like a zoom feature, you start like noticing like the scene renders fine. It's just it looks like the shadows and the lights are not updating in the and it kind of looks like a grid pattern. So it kind of looks like the camera plus cluster.
Okay. No, it'll get solved. It's not really a graphical issue at all. It's just a
Mhm.
logical issue in the calling thread.
All right.
But yeah, it'll get worked out.
I got something else with the terrain.
Hmm.
For example, if you work on a terrain and you will lower the size, it's not that possible because you have no value. So yeah, I tried to flatten an terrain again to the 0 point at some places, and it was pretty hard.
Because it goes below the ground. Because it
Yeah,
goes below. That's a it's a feature. Yeah, in Leadworks, like the lowest you could go was 0. And in Ultra, we're using I think it's using a 16-bit float. So if you lower the terrain back to the floor, then it'll just keep going into the floor because people wanted to be able to raise and lower the terrain. So how
yeah,
would you
that's nice.
suggest?
In Unity, and I think also in Unreal, you have a different tool. So you can raise the terrain at circle, for example. It's a circle stamp, and if you push the left button, the terrain get raised to the value you set up before. So you
Okay.
can increase the terrain height at this point, for example, to 50 or to -25, and
Okay,
so
that
you
seems like a good actually seems like a good solution. So like you would have a tool to like set the terrain height at a certain height. And in your case, if you want it to go back to the floor, then you would just input 0. If you want somewhere else, then I think that's a good idea. I agree. Like I think we can do that.
Yeah, that's nice, and also maybe some smoothing texture like in Networks. I think it was a function you can make a terrain smooth. So if you have yeah if you have
Yeah,
some nice
absolutely. I just implemented like the basics to in order to get it working, and I think we can agree. You know, getting this resolved is priority number one. But yeah, smoothing should be in there, and also I would actually like to have hydraulic erosion. It looks like I have some code. I think I sent it to you on Discord actually. In that terrain
yeah
generation code that I wrote that includes some hydraulic erosion stuff, I think, and that's really nice because you just if you just do like a diamond square pattern and then add some hydraulic erosion onto it, it makes it look like it forms like these little like rivulets and gullies and stuff. It looks very much like the mountains in like Southern California. I think that looks. If you could just go and like paint that anywhere on the terrain that you wanted, I think that would be a very cool feature to have too.
this would be cool.
Yeah.
And also this rise or lower terrain tool that you can, for example, use this tool, set it to 0, and then you can reset the terrain on some places to 0, or you even could raise the terrain, for example, at some points to be a bit higher. I
Yeah,
think
I agree.
I think the best example, I'm not sure if you ever played the World of Warcraft Classic, but there is an area it's called Thousand Needles, and I think they made this with a tool like this. So
What is it
they
called?
just Thousand Needles is something like you can see it. This is a tool like this. I can post a screenshot. Great.
Yeah, please.
I just checked for a good one. Yeah, here's a good. Yeah, I posted in this channel. You can see they use a tool like this. They
Oh yeah.
rise the terrain at one point, and then they make some stuff like this. So
Yeah, I think that would be very useful. Like beyond, I mean, we had the flatten tool in Leadworks, but being able to input the exact value, I think would be very useful. So yeah, I can't say exactly when, but I agree that I will do that. Also with the prefabs, like I need to put that on hold for now because like this graphical stuff is turning into a little bit more work. Like it's just work I wasn't planning on doing yet, but I might as well. I mean, since I have to do it, it'll, like I said, it'll make a low end fallback a lot easier. So I need to focus on that for the rest of the month. But then after that, then we can, I think I'll be able to give prefabs like the dedicated time that it deserves. Because it's clear that people want to use them heavily, and they also like are very they want the like the per prefab flow graph logical connections to work like within that prefab. So I just want to. I think I should get the graphical stuff knocked out first, and then when I'm able to focus on the prefab stuff, then I can do it properly and have a result for you that's not like haphazard.
Alright. I have a question only because I'm looking at it. You recently changed the events to accept the weak pointer instead of a um a shared pointer.
Internal, it
Um,
still accepts a shared pointer, but internally it's stored as a weak pointer
all
so that
right,
it won't create those circular
all right,
references.
all right. In my project, I'm now getting an exception when the app closes. Construct from weak, and it stops when the app closes. I can send you the project, but
Please do.
yeah, it just started when I updated it,
Okay.
and I yeah so
Yeah, and that sounds like something that will be. That seems like something that will be very easy to fix once I see the bug. Like once I see the
Yeah,
behavior, I think it'll be easy to
yeah,
fix.
yeah. It's a very small project. All you have to do is just press generate VS step that use Premake to generate the project. So everything should work.
Okay. All right. Yeah. Thank you.
No problem. Um, alright.
Who's this Fox person? I haven't seen them here
Um,
before. I'm just listening.
Yeah, hi.
Hey.
I'm Wildfout Studio. We did spoke on Discord actually on text.
Oh, okay. Okay, cool. Welcome.
Sorry, I'm just here to listen. Thank
I'm
you, man.
just listening. That's fine. We're happy to have you here.
Thank you.
Any other questions? Okay. Well, you guys voted, and you said that you wanted that this was a big concern to you, and this is not a democracy. We don't always like do things based on voting because that's not a good way to do things. But sometimes I do. I always value your feedback, and you wanted this fixed, and now I solved the problem and described the whole situation to you in probably a lot more detail than you ever wanted to know. But hopefully everyone learned something today, and this will be resolved soon in an update. I'm estimating 2 weeks to finish this, which puts us right on time. Yeah, 2 weeks, a little bit less. Might not be exactly that. I never know for sure, but yeah, it's the fix is coming, and then after that, I'll be able to turn my attention back to prefabs and the vegetation system, which is actually going to be. I'm just porting code, so it's not going to be that difficult to do. I don't think. I'm not going to try to do any new major innovation in that. I'm just going to get it working in Ultra, and then we can decide what we want to do from there. So, unless there are any other questions, we'll wrap this up today. Thank you all for coming, and thank you for listening to my very long explanation.
it wasn't long. We have 15 minutes left.
Yeah, but I felt I was using a lot of words to describe all the GLSL stuff.
Yeah.
Okay.
It is interesting.
Yeah, it's just like they really like lost me, and I used to, when I was like more of a beginner programmer, I would read something like that, and I'd be like, oh wow, there's a lot of like smart people who understand every word of this, but you get to a certain point, you realize nobody really understands this. Like,
It's just smart talk.
yeah, basically. I mean, they're like using a lot of words to like cover all their bases, but it's not really saying like you'd have to be an engineer you'd have to be the person who wrote the drivers for each company to even understand that. So
It's like law text or something.
yeah.
Everything is clear. I read a little bit book about shaders and everything is clear.
Okay, well, we've got a smart person here. Really? Do you like everything about dynamically uniform expressions and invocation groups and that? Your microphone is muted, I think.
I read a little bit about basic stuff, but information about Vulkan part is a little bit too complex for me in general. But I think that this time it will be more clear.
Yeah, yeah. It's complicated stuff, but it's a lot of fun. What book was it actually? His microphone is muted again. There's a book. Actually, I keep saying I want to read, but I never have. It's called, the entire thing is about visualizing. Is it pronounced quaternion? Quaternion? Quaternion rotations. There's an entire book because they're not. It's not just a. Those rotations are not just a like a vector and an angle. It's something. It's like a 4-dimensional rotation, and there's an entire book about how to sort of like visualize them. And I would love to read that so that I can truly understand them. Like, the only way I really got them working is just by like following the math. Yeah, once you get to a certain level, it's like everybody's like becomes very specialized, and like two specialists typically. I've seen this also in science. Like two specialists will have in slightly different areas have a lot of trouble talking to each other because they don't really understand each other's area of expertise in very great detail. So, anyways, I'm just happy that the problem is solved, and thank you guys for pointing me in that direction because I agree it was a big issue, and I'm happy to have that resolved. And thank you for your patience while that's getting finished. So, yeah, with that, we'll call it. We're actually 10 minutes early today, so everyone is excused early. Have a good weekend, and I will see you all on the forum.
Yeah. Bye.
You too.
Thanks.
Thank you.
See you later.
See you guys.